You know, I've been a mechanic for over 15 years, and it never ceases to amaze me how little people know about their automobiles. Think about it. We spend thousands of dollars to buy a car and hundreds of dollars each year to insure and maintain them, but the fact is, most people don't know the first thing about what goes on under the hood. Now, if you're one of those who feels helpless around their car, and you're getting a little tired of paying your mechanic every time your car needs a simple minor tune-up, take heart, because all that's about to change. In the next few minutes, I'm going to show you how you can save a bundle by learning how to tune your own car. You don't need a fancy shop, and with just a few of the right tools, you can do it all right in your own garage. You don't believe me? Stick around, I'm going to show you how. My name's Geraghty, and this is the Automotive Tune-Up Guide. Cars are built to withstand all kinds of punishment, but the engine is a precision instrument, so it's natural for parts to wear out and for engine settings to need adjustment from time to time. That's all a tune-up really is. In fact, no matter what kind of car you drive, compact, full-size, light truck, sporty, practical, older or new, the tune-up procedure is always basically the same. Its main purpose is to maximize engine performance and fuel efficiency. Now keep in mind, I'm not talking about a major engine tune-up, which in addition to what we're about to do might consist of a valve adjustment, servicing of the carburetor or fuel injection system, as well as some other diagnostic procedures. I think I'd leave all that for your mechanic to do. What I'm talking about is that simple minor tune-up, which to have your car run at its best, should be done at intervals ranging from 8,000 to 12,000 miles, or whenever you notice any increase in fuel consumption. Let's go over the tune-up procedures now, step by step. First, we'll replace the air filter. Then, we'll replace the fuel filter. Next, we'll gap the spark plugs. After that, we'll replace the spark plugs. Then, we'll replace the spark plug wires. Then, we will replace the distributor cap and rotor. And if you have a conventional ignition system instead of an electronic one, we will replace the points and condenser and set the dwell. Next, we'll check the vacuum lines. Then, we'll check and if necessary, adjust the ignition timing. And finally, we will check and adjust the idle mixture, if adjustable, and the idle speed. All automobiles are made up of a group of systems: fuel, exhaust, suspension, cooling, brake, ignition, and so forth. Now, when all these systems are functioning properly, they combine to produce a smooth and fuel-efficient ride. But because they operate together as well as independently, when something goes wrong with one system, it can seriously affect the operation of another. The ignition system does tend to require more frequent service, so keeping it properly in tune is very important. But don't be fooled or misled by many of these quickie tune-up shops that offer tune-ups at cut-rate prices. Many of them don't do as thorough a job as we're going to do, and quite often their parts are inferior. And speaking of parts, here are all the parts you'll need. First, you'll need an air filter, and yours will probably resemble one of these. A fuel filter, again like one of these. A set of spark plugs. A set of spark plug wires. A distributor cap and rotor, and if you have a conventional ignition system, then you'll need a set of points and possibly a condenser. Now, each car will have certain tool requirements of its own, but here are some of the basic tools you'll need: a flat blade and a Phillips head screwdriver, a pair of vice grips, a 3/8" drive ratchet, a 3/8" drive 6 and 12" extension, a swivel type spark plug socket, and this tool. This is called a feeler gauge. You'll also need a set of metric sockets and end wrenches 8 through 19 millimeters for most foreign vehicles, and a set of standard sockets and end wrenches 5/16 through 3/4 of an inch for most American cars. Now, if you're serious about tuning your car this time and in the future, I recommend that you purchase a set of quality tools. Good quality tools are sure to make the job go quicker and easier, and as for their cost, these tools will easily pay for themselves after the first few tune-ups. Now, the last two tools you'll need are a timing light and a tach dwell meter. These two instruments are what you're going to use to tune your engine precisely. The timing light, actually a strobe light, contains a tiny xenon bulb, which, when checking ignition timing, allows us to see the timing mark while the engine is running that would otherwise be invisible to the naked eye. If your car is not equipped with a tachometer in the dash, or if you have a standard ignition system with points and a condenser, then you'll need a tach dwell meter. More about this equipment a little later. Now that I've introduced you to the tune-up procedures and reviewed all the necessary tools and parts, we're all set to go. But before we get started, one final thing. While working around your automobile, safety is essential. So I recommend that you view the program at least once all the way through, and please pay particular attention to the safety tips. Okay, get ready because your relationship with your automobile is about to make a big change for the better. Let's get at it. Here's step 1, replacing the air filter. Now the air filter is designed to remove foreign particles from the engine's air supply. As you can see, air filters can vary in size, but really only come in a few basic shapes. A plugged air filter is sure to cause poor gas mileage. It may be time to replace your filter if you notice any trace of black smoke coming out the tailpipe of your car. For some of you out there with a rectangular shaped air filter, you may find it easier to unsnap the 4 clips that hold the air filter housing in place with a long screwdriver. If you're working near the battery, which is frequently the case, be sure not to lay the screwdriver on the battery or any other tool for that matter. Unlike the round-shaped air filter, which can be fitted either way, make sure that this filter is installed right side up. And when you're done, don't forget to fasten the 4 clips. This round-shaped air filter is by far the most common and is usually located at the top center of the engine compartment. To replace it, you shouldn't even need any tools. This filter has no top or bottom and can be fitted either way. Just undo whatever fasteners hold the lid in place. And remove the old filter. Now this dirty air filter literally suffocates the engine by impeding its air supply, causing poor fuel economy. Here's a quick and easy test to check the condition of your air filter. Shine a flashlight through it. If the light can't get through, you can be sure that air can't either. Now take the new filter, put it back into the air cleaner assembly, put the lid back on, reattach the fasteners, and that's that. The fuel filter is designed to remove impurities from the engine's fuel supply. Inside the plastic or metal casing is a wire screen or filtering paper. There are 2 types of fuel delivery systems, carbureted and fuel injected. If your vehicle's engine is fuel injected, then the filter will look like one of these high pressure types. And if your engine is carbureted, then your fuel filter will resemble one of these low pressure type filters. Or it might resemble one of these. These filters are found on many GM and Ford cars. I call these insert types. Many owner's manuals recommend that you replace your fuel filter at intervals ranging from 30,000 miles all the way up to 60,000 miles. But when you consider that a particle the size of a grain of sand can seriously affect your fuel induction system, it makes sense that you replace your filter much more often than that. It's just good preventative maintenance. A good rule of thumb to follow is, the smaller the filter, the more often it needs to be replaced. Now, believe it or not, I've stopped to help more drivers stuck alongside of the road because of a plugged fuel filter than for just about anything else. The symptoms of a plugged fuel filter, loss of power, and possible backfiring, usually occur when the vehicle's traveling up a hill. Now, the fuel filter locations on many carbureted vehicles can vary, but they're usually easily visible somewhere in the engine compartment. All you'll need is a screwdriver or a pair of pliers, and maybe a pair of vice grips. All fuel filters are marked with an arrow to indicate the direction that the fuel must flow through the filter. So before you start, hold the new filter next to the old filter that you're going to replace to make sure that you're connecting it properly. All you do is remove the filter from its bracket. Then with either the pliers or screwdriver, loosen the fasteners that hold the fuel lines to the filter. Slide the fasteners down the fuel line and out of the way, and pull the fuel lines off the old filter. On many cars, a little gas is likely to seep out, so be careful. On some cars, fuel may continue to flow out steadily. If this happens to you, take a pair of vice grips and gently crimp the line. Install the new filter in exactly the same way you removed the old one. If you have used the vice grip to pinch off a line, be sure you remove them or you won't be going anywhere. Remember to tighten any fasteners. Then start the engine and check for any leaks. On certain vehicles, such as some Mazdas, Nissan pickups, Hondas, and others, you'll sometimes find the fuel filter underneath in the rear of the car. Some filters may reside in a housing, and some might be located under the back seat or even in the trunk. Also, some cars might have two fuel filters, a primary and a secondary. The people at your auto parts store should be able to tell you if your car does. Some Chrysler and Subarus may have a filter that has 3 nipples instead of 2. Some Fords have a filter that's located just inches from the carburetor, and other Fords have a filter that's screwed right into the carburetor itself. To get to the fuel filter, you'll have to take off the air cleaner assembly. This might require the removal of some hoses, so note their locations and be sure to reconnect them when you're done. To replace this type of filter, first loosen the line nut that secures the line to the filter. Remove the fuel line from the filter and using a crescent wrench, or the proper sized end wrench, unscrew the filter from the body of the carburetor. Take the new filter and start it into the carburetor by hand. Once you're sure the threads are started correctly, finish tightening the filter with a wrench, reinsert the fuel line into the filter, tighten the line nut, and you're all done. Once again, start the car and check for leaks. For most of you GM owners with carbureted vehicles, and some of you Ford drivers out there, you'll need to install one of these insert type filters. Now these filters are so small, I suggest you replace them between every 6 and 12 months. Now as with the Ford filter we just replaced, you'll have to remove the air cleaner assembly. Okay, now while holding the filter body with either a 1-inch end wrench or a crescent wrench, take the fitting wrench and break the line nut loose. Once it's completely loose, remove the line nut and the fuel line from the filter body. Move it out of the way. Take the 1-inch end wrench or the crescent wrench and loosen the filter body now. Again, give it a couple of turns, then you can probably just remove it with your fingers. Okay, remove the filter body and pull it away from the carburetor. Now there's a spring inside the carburetor. Make sure you leave the spring in there. Unlike other fuel filters that have a flow direction arrow, this filter has a hole in one end and no hole in the other. Make sure that the end with the hole points toward the line nut. So there's the hole into the filter body that way. And reinsert the filter body into the carburetor. Now tighten the filter body into the carburetor, again with the 1-inch end wrench or a crescent wrench. Reinsert the fuel line into the filter body. Wiggle a little bit, get that line nut to start. Hold the filter body again with the end wrench or crescent wrench. And that's all there is to it. Now that I've shown you how to replace the fuel filters on some carbureted vehicles, let's move on to the fuel-injected filters. Fuel-injected filters typically are capable of withstanding higher fuel pressures, which is the nature of fuel injection, as opposed to the lower pressure carbureted types. So quite often, threaded fittings like these are used instead of nipples with hose clamps, although these are sometimes used also. Replacement of the fuel-injected type filter with nipples and hose clamps is not unlike replacing the standard plastic filter in carbureted vehicles. The filter is normally secured in a bracket which holds it in place. The clamps must be loosened on both ends of the filter so that the fuel lines can be removed and the new filter installed. Many times, fuel-injected filters will require wrenches for removal and replacement. Another characteristic of fuel-injected systems is that they maintain fuel pressure even after the engine is shut off. So, to avoid being sprayed with fuel, be sure to cover the filter and its ends with a rag. Also, after replacing one of these types of filters, it's normal for the engine to crank for several moments until the filter fills with fuel before the car will start. Now, first of all, disconnect the negative battery terminal. Slide that cable up and out of the way. And for extra safety, cover the positive end with a rag. Now, on each side of the threaded type fuel filter are 6 sides known as a hex. Hold either filter hex with an end wrench of the proper size and break each banjo bolt loose with an end wrench. Once they're loose, you can use your fingers, and there are little sealing washers, one on each side of the fuel line. Don't lose those. Loosen the clamp that secures the filter to its bracket. Slide the clamp down across the bracket. Take the new filter, slide the clamp over it, set it down in its bracket, but don't tighten that clamp just yet. Now take the banjo bolts, and remember these little sealing washers, and start them into the filter with your fingers to avoid cross-threading. Now grab that filter hex again, that end wrench, and tighten those banjo bolts. Now tighten that clamp that holds the filter to its bracket. Reconnect the negative battery cable. And start the engine and check for leaks. And that's that. Okay, so now that we've already completed the first 2 steps of the tune-up, it's time to replace the spark plugs. The purpose of the spark plug is to provide a gap inside the combustion chamber where extremely high voltage forms a discharge, or spark, to ignite the compressed mixture of fuel and air in the cylinder. Now, spark plug gaps may vary with each engine type, so before we replace the spark plugs, it's necessary to gap them to the manufacturer's specifications. Now, this information can be found in your owner's manual or at any auto parts store, and sometimes you'll even find your spark plug gap specification on the emission control decal located under the hood of your car or somewhere in the engine compartment itself. More about the emission control decal later. The object here is to adjust the width of the gap between the positive electrode here and the negative electrode here. This is easily done with the feeler gauge, which contains strips of varying thicknesses. Now, if your spark plug gap was, say, 0.035 or 35,000ths of an inch, then you would select the blade of the feeler gauge marked 0.035. Run the blade of the feeler gauge between the 2 electrodes. It doesn't have to be exact, but your car will run at its best if you're at least somewhere close. Now, this plug is properly gapped at 35,000ths of an inch. I know this because the blade of the feeler gauge is making contact with both electrodes at the same time, sliding between these 2 points with very little resistance. As the name of the tool implies, you must rely on your sense of feel. This plug is gapped too tightly. I can barely slide the feeler gauge through it. To open it up, take the blade of the feeler gauge and pry up ever so slightly. Once you're satisfied that the gap is correct, go on to the next plug. Now, this plug is too loose and the gap must be reduced. To reduce the gap, gently tap this end of the spark plug against this portion of the feeler gauge or against any hard surface. As we did before, I'll run the blade of the feeler gauge between the 2 electrodes like so, And again, I'll rely on my sense of feel to assure myself that the plug is now properly gapped. Spark plug gaps may vary from as small as 0.024, 24 thousandths of an inch, to as much as 0.080, 80 thousandths of an inch. This means that some gaps will require that you combine 2 or more strips of your feeler gauge to arrive at the correct total. For instance, many American cars gap at 0.060, 60 thousandths of an inch. So in this case, you would combine the 0.019 strip with the 0.020 and 0.021 strips for a total of 0.060, 60 thousandths of an inch. Okay, once you've gapped all your spark plugs, you're ready to install them. One reminder though, before you proceed, spark plugs are vulnerable at this point, so don't drop them or otherwise change their gaps. If you do, always be sure to recheck them. The tools you'll need to replace the spark plugs are either the 5/8" spark plug socket, which fits many Ford and GM vehicles, or the 13/16" plug socket, which fits most all others. Now I recommend a swivel type plug socket, but if you don't have one, that's okay. You'll also need an extension and the ratchet. Simply assemble them in this manner. Now it doesn't matter if you have an inline engine with all the plugs in one row, or a V-type engine with plugs on each side. On most cars, spark plugs are usually very easy to remove and replace. With certain GM V engines, however, the spark plug arrangement can be awkward, and removal of the spark plugs is best accomplished by raising the car one side at a time with a bumper jack and going in over the wheel with a long extension. But as I said, this is the exception and not the rule. Some Nissan models have what's called a NOP-Z engine. In this engine, a 4-cylinder inline, there are 2 spark plugs per cylinder, with spark plug requirements clearly visible atop the valve cover. As you can see, each spark plug is connected by a spark plug wire to a specific tower here on the distributor cap. In removing or replacing any plug wire, it's extremely important to make sure that each plug wire returns to the proper receptacle. To make sure that you don't accidentally cross the plug wires, it's always a good idea to replace them one at a time. There is a delicate core inside the plug wire, so gently twist it and pull it off the spark plug. Now, slip the socket over the plug and crack it loose, turning from right to left, just as you would unscrew a light bulb. Next, take your new gapped spark plug, slip it into the socket, fit the socket back into the hole, and start it in gently at first with your fingers. By doing it in this way, you'll be assured of not cross-threading the plug. If the plug doesn't go in smoothly, take it out and start again. Once you're sure the plug is started correctly in the hole, go ahead and attach the ratchet, reverse the direction of the ratchet, and bring it down until it feels snug. And then you go just a bit tighter, maybe a quarter to a half a turn. That's about as tight as a spark plug needs to be. Now reattach the spark plug wire and repeat the procedure for the remaining spark plugs. As I mentioned earlier, it will be necessary to replace your entire spark plug wire set from time to time. Due to the extreme heat put out by the engine, it's not unusual for these wires to crack, form bubbles, or even to break. In addition, you can't always identify a bad plug wire by the way it looks. Accurately assessing the condition of the wires would require a mechanic's oscilloscope. First, lay out your new spark plug wire set. Now you'll notice that one wire looks a little different than the rest. This is the coil wire. Remove the old coil wire, which is located between the coil and the center tower of the distributor cap, and replace it with the new one. Now, remove any one spark plug wire you like and choose the new wire that most closely matches it in length. And replace the wire between the 2 vacant terminals at the spark plug and the distributor cap. It's just that simple. If you replace these wires one at a time, I guarantee you'll never go wrong. Starting in the mid-1970s, most car makers began to manufacture their cars with electronic ignition systems. Now that single development has simplified the tune-up by eliminating a set of points and condenser within the distributor to replace and adjust. For those of you with that conventional type system, sit tight. I'll demonstrate point and condenser replacement in just a minute. For now though, I'm going to start by showing you how to replace the distributor cap and rotor, which both systems have in common. Now the distributor will always be located in the engine compartment and is usually easily accessible. The distributor caps on many vehicles are secured by clips, which you should be able to easily remove with just your fingers or a blade screwdriver. In addition to this type of hold down, there's also a screw type hold down and a hex head type hold down. To remove either of these, just use the appropriate screwdriver or socket. This is the distributor rotor. Some rotors are held in by screws, but others like this should slide out of their slot quite easily. Sometimes they're sticky though and must be wiggled loose. Now take your new rotor, which incidentally only goes in one way, and place it on the distributor shaft. Turn it in a circular motion till it slides into place, and push it in firmly. Before we replace the distributor cap, let's briefly inspect an old one. What you want to look for are cracks, carbon tracks, or any traces of moisture. Any of these faults could cause your car to run very poorly in all phases of its operation. Now I'll place the new distributor cap back onto the distributor. Note that it too only fits on one way. To secure it, just reattach these little spring clips. Now I'll transfer the spark plug wires from the old distributor cap to the new one, making sure as I do that each wire is routed as it was originally. For some of you out there with certain makes of GM cars, there exists what is called HEI, high energy ignition. Now HEI is capable of delivering much higher voltage than other ignition systems and can be found in 4, 6, or 8-cylinder vehicles. On this type of ignition system, you'll notice that the receptacles are male instead of female, and that there is no center tower on the cap because the coil is located inside the distributor cap itself. The HEI cap is more expensive than most conventional distributor caps, but it generally tends to last longer. However, because of the strain of conducting such high voltage, the HEI rotor does tend to require replacement at more frequent intervals. To remove the HEI distributor cap, it may be necessary to lift the air cleaner assembly out of the way slightly. Usually there are 2 plastic clips that hold the spark plug wire harness in place. Release these clips and move the harness out of the way. Now, unfasten the small wires from the distributor cap. Don't worry about reconnection, they only fit back in one way. There are 4 hooks that attach the distributor cap to the distributor. With a blade screwdriver, exert only slight pressure on each screw and turn it about 1/2 turn in a counterclockwise direction. The cap will lift off, and you should examine it for the same possible faults I alerted you to previously. To remove the HEI rotor, you will need either a Phillips head screwdriver or a 1/4 inch socket. Unscrew the 2 fasteners that hold the rotor in place, and lift and remove the old rotor. Attach the new rotor, which again only goes in one way, and refasten it. Remember, this is plastic, so don't break it by over-tightening. To reattach the HEI distributor cap, rotate it until it drops into place, and with the blade screwdriver, rotate the hooks back to their original positions. Now that the cap is secured, locate the small wires that you previously disconnected and reinstall them. The spark plug wire harness must now be reconnected. Install it on top of the cap and wiggle each wire until you're sure they're seated. The 2 plastic clips will snap into place and you're done. As you know by now, standard ignition systems require the replacement of points and sometimes a condenser. Now, ignition points are sometimes referred to as contact points or breaker points. There are several different styles of points, but really they're all basically the same. Before you start though, it's always a good idea to study the points and condenser for a moment and to note the way in which the wires are connected to them. To replace the points, first remove the little wire or wires that attach the points to the condenser lead. lay it out of the way. Now, contact the screw or screws that hold the points in place and turn them until they're completely loose. And lift the screws and the points out of the distributor. The condenser, located in or affixed to the side of the distributor, should last up to 80,000 miles and normally won't need to be replaced. But if you notice a distinct fogging on the points, then the condenser probably does have to be replaced. When you install the new condenser, make sure the screws are tight. Loose screws can cause big problems. Now, clean the distributor cam with a rag and lightly grease the cam with point lube. This is an inexpensive grease found in most auto parts stores. Now take the new set of points, and if they have a protective piece of paper between the points, be sure to remove it. Drop the points into the distributor. Start the screws into the hole, gently, not firmly, so that the points can still move. Now revolve the engine like so until the toe of the cam begins to contact the rubbing block of the points squarely. To do this, if you have a standard transmission, you can revolve the engine by putting the car in its highest gear and rolling the car ahead slightly. If you have an automatic transmission, apply a wrench to one of the pulleys, like so. In either case, return the vehicle to neutral and don't forget to remove any tools. Next, open up the points about the width of a matchbook cover and tighten them, making sure as you do that you don't bend the points with the blade of the screwdriver. Put the rotor back on and the cap back on, and now you're ready to set the dwell, which will require the use of the tach dwell meter. If your car is not equipped with a tachometer in the dash, then you'll also need this instrument to register the RPM in the final tune-up step, adjusting the idle speed. Most dwell meters have two leads. One will be either red or green, and the other will be black. Connect either the red or green lead to the small post on the coil, which is marked by the minus sign. The other small post on the coil will have a plus sign. Don't connect it there. Now take the black lead and connect it to the negative battery terminal. There are several different styles of coils. The one you've just seen is the most common, but if your coil has the words dist and bat on it, then connect either the red or green lead to the dist terminal and the black lead to the negative battery terminal. On certain Ford models, you'll find a terminal that is lettered tach test. You can gain access to this terminal with a probe to which you should connect either the red or green lead and the black lead again to the negative terminal on the battery. For you GM owners with HEI, high energy ignition, you can likewise gain access into the negative side of your coil with this inexpensive gizmo called a coil tap. Simply snap the coil tap into the terminal in the distributor cap labeled tach and connect either the red or green lead of your tach dwell meter to it. Once again, connect the black lead to the negative terminal on the battery. Now, once you've acquainted yourself with the tach dwell meter, which will come with easy to follow instructions, and after connecting it in one of the methods I've just demonstrated, then you'll need to set the dwell. Dwell is a very accurate method of adjusting the gap of the points and will always be listed by degrees in either your owner's manual, your shop manual, or your emission control decal. On most pre-1974 GM cars, you can set the dwell with a small Allen wrench through a little window in the distributor cap. Unlike other dwell adjustments that are made while the engine is off, the dwell adjustment on these cars can be made while the engine is running. However, I recommend that for safety's sake, you make any necessary adjustments with the engine off. The points on this demonstration vehicle, for example, are allowed between 49 to 55 degrees of dwell, or 49 to 55 degrees of camshaft rotation while the points are closed. Now, many dwell specifications do give you a generous spread to work with, and accurate adjustment will maximize ignition capabilities. To check the dwell, the engine must be running. If upon checking the meter you find that the dwell reading is low, say at 40, this indicates that the points are too far open and should be closed slightly. If upon checking the meter you find the reading is high, say at 60, and the manual gives you 49 to 55 degrees of dwell, this indicates that the points are too tight and must be opened up slightly. If you're within the dwell tolerances, then obviously no adjustment is necessary. If adjustment is necessary, shut off the engine, remove the distributor cap and the rotor, and loosen the screw or screws that hold the points in place, and make a very slight adjustment. Now, grease or even the smallest trace of dirt between the points can prevent the car from starting. To safeguard against this, run a clean matchbook gently between the points, and this should eliminate any potential problem. If you haven't adjusted the points within their specification, the car again may not start. If this happens to you, go back, make a slight adjustment, and check the dwell meter again. It may take a few tries, but don't worry, you'll get it. Now, vacuum lines route vacuum to various locations around the engine. They're made of rubber, and like spark plug wires, they're vulnerable after some time to wear and tear, as well as the tremendous heat that circulates in and around the engine compartment. Knowing how to identify a bad vacuum line could save you an unnecessary repair bill, or even a ride in a tow truck. Now, what you want to look for are cracks, or any line with a bad fit. If you locate a leaking vacuum line and you don't have enough slack to trim it off, then you would have to replace the whole thing. Quite often you can hear a leaking vacuum line. It makes a hissing sound. For demonstration purposes, I'm going to induce a vacuum leak for you now to show you just what I mean. Now, a leaking vacuum line could cause your car to lug, hesitate, get poor gas mileage, or even to overheat. There, that's better. Let's move on, shall we? Following proper safety procedures while working on your vehicle is very important. So before we get to the last two steps of the tune-up, let's go over a few safety reminders. First, place the automatic transmission shift lever in the park position. If you have a manual transmission, place the stick in neutral. And be sure to securely set that parking brake, and if necessary, you might even want to block the wheels. Avoid bringing hookup leads from the timing light and tachometer over the engine's fan, pump, and belt areas. Whenever possible, route these leads outside the engine compartment. Whatever you do, don't lay tools or any other equipment on the battery, and always make sure to remove all tools from the engine compartment before starting the engine. Never wear neckties, jewelry, or loose clothing when working around the engine. Be sure to keep hands and hair away from all moving parts, and also keep lit cigarettes and any other ignition sources out of the engine compartment at all times. And last, always make sure that when the engine is running that you have proper ventilation. Okay, now we come to the last two steps, ignition timing and idle speed. This is where we actually tune the engine. Now, what is ignition timing? Well, it's the precise moment when ignition occurs in each cylinder. If the engine's timing is incorrect, the symptoms can range from a loud pinging sound to poor engine performance and overheating. Each engine type, because of size, horsepower, and other factors, will have its own set of tune-up specifications. Consequently, ignition timing can differ from one model of car to another. This information is available in your owner's manual or from your nearby auto parts store, but the best place to get your tune-up specifications is from the emission control decal located under the hood of your car or somewhere in the engine compartment, usually easily visible. Starting in 1970, this decal was posted by law to alert drivers and mechanics to the emission control systems that were originally included on the vehicle. In addition to listing year and engine size, it also includes various tune-up specifications, such as ignition timing and idle speed. If there is no emission control decal located under the hood or anywhere in the engine compartment, then chances are the vehicle has been involved in a collision and the hood has been either repainted or replaced. You might want to keep that in mind, particularly if you plan to buy a used car. And by the way, for demonstration purposes, the hoods on our vehicles have been removed, but to tune your car, that won't be necessary. For some of you with late model computer controlled cars, you'll notice that the emission control decal might indicate that the timing and or idle speed are non-adjustable. If your car falls into this category, then the last two tune-up steps won't apply to you. But if the decal indicates that the timing and or idle speed are adjustable, then stick around, because there are a couple more things left to do. Now, what most engines have in common is a timing mark and an index scale, with the timing mark on what's called the engine's front pulley and the index scale on what's called the timing cover. On some engines, however, the timing mark and the index scale will be found at the timing window at the rear of the engine. Many of these windows will have a protective plastic or rubber plug or cap over them that can be removed either by hand or with a pair of pliers. Now, the object in checking ignition timing is to make sure that when the engine is running, that the pulley notch is in alignment with the appropriate mark on the index scale on the timing cover. Now, for instance, if the timing specification for your car was, say, 12 degrees BTDC, then you would want to line up the pulley notch with the mark on the timing cover that has the 12 next to it. And if your timing specification was, say, 4 degrees BTDC, then you'd want to line up the pulley notch with the mark on the timing cover that has the 4 next to it, and so on and so forth. Now, adjusting the timing is done by loosening and then moving the distributor a small amount. I'll demonstrate that shortly. And don't let the term BTDC throw you. TDC is always 0 on the index scale. The B in BTDC simply stands for before top dead center. Now, some cars might indicate an ATDC setting. That simply stands for after top dead center. Referring to the emission control decal under the hood of our demonstration vehicle, the timing specification is 10 degrees BTDC. Again, as you can see, there is the notch on the engine's front pulley, and there is the mark with the 10 next to it. To see it even more clearly when I check the timing, I'm going to accentuate both marks with a fine piece of chalk. Why don't you do the same? Now, if it so happens that you don't see the timing mark on the front pulley, don't worry, there are several ways of locating it. You can sometimes find the timing mark by crawling underneath the car, or you can connect what's called a remote starter switch, or with the help of a friend sitting behind the wheel, tapping the key, the pulley will turn and the notch will soon appear. Watch, I'll show you. Again, 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 again. There it is. Do you see it? Now, for most of you, depending on your make and model of car, there will probably be a preparatory step that must be taken just before you can check or adjust the ignition timing. Now, this step normally requires the disconnection of certain vacuum lines or of an electrical circuit. You'll find these instructions on your emission control decal located somewhere under the hood. For some Ford owners, disconnect what is called the spout connector. And for many computer-controlled cars, it may be necessary to disconnect a 1-wire connector or a 4-wire connector, which is located near the distributor. If your decal indicates grounding the ALDL, then, with the engine running, insert a paper clip between these 2 points if you have a 5-pin connector, and between these 2 points if you have a 12-pin connector. The check engine light may flash on, but that's okay. A word of caution here: be sure to remove the paper clip after checking the timing and before shutting off the engine. This is very important. And for some of you VW owners, if your decal indicates that you must bypass what's called the idle stabilizer, all you do with the engine off is remove the two plugs from the stabilizer and simply connect them together. Start the engine, and after you have checked or adjusted the ignition timing, then turn the engine back off again and reconnect the two plugs back into the stabilizer. If there is no disconnection step spelled out on the emission control decal, then that means that there's nothing to disconnect. But by far, the most common instruction given just prior to checking the timing is the disconnection of a vacuum line located here at the vacuum diaphragm located next to the distributor. Now there are lots of things you can use to plug this line. I'll use this golf tee. Some decals might indicate that there are two vacuum lines present at this diaphragm, in which case you should disconnect and plug both of them. So now that we've completed the preparatory step, we're ready to move on. In order to properly set the timing, the engine should be running somewhere under 1,000 RPM. To measure this, you'll need the tachometer in your dash or the tach dwell meter. Remember, the instructions for connecting the tach dwell meter are in the earlier segment, point and condenser replacement. If the engine is cold, it will probably take a few minutes for the engine to warm up enough for the idle speed to drop down into that RPM range, but that's normal. If for some reason your engine is running over 1,000 RPM, then the idle speed should be reduced before proceeding any further. Now it's unlikely that this will be the case, but if it is, move ahead in the tape to the last procedure, reduce the idle speed, and then return to this step. As you can see by the reading on the tachometer, the engine is now idling under 1,000 RPM, so we're ready to check the timing. Now the timing light has three leads. A black lead, which you connect to the negative battery terminal, which is marked by a minus sign. A red lead, which you connect to the positive battery terminal, marked by the plus sign. And the last lead, which you connect to the number one spark plug wire. Now on an inline engine, the number one spark plug wire is always attached to the spark plug closest to the fan belt or belts. Two other very common number one spark plug locations are on Subarus and many Ford V engines, where the number one spark plug is located furthest front of the engine on the passenger side, and on many GMs, Chryslers, and AMC V engines, where the number one spark plug is located furthest front of the engine on the driver's side. Now by pulling the trigger, we activate the timing light. Now let's aim the timing light at the engine's front pulley to see if the notch on the pulley is in alignment with the number 10, which is our timing specification. There are the two marks, but as you can see, the notch on the pulley is not quite in alignment with the number 10, which is our timing specification. If they were, then of course the timing would not have to be adjusted. But since they're not, what I'm going to do is to loosen the distributor so that we can properly set the timing. This will normally require the use of a socket or end wrench, or sometimes a special tool known as a distributor wrench if your distributor hold-down bolt is in a particularly difficult location. Use your best judgment and select the right tool. Now, turn off the engine. Take the socket or end wrench and place it on the bolt that holds the distributor in position. Loosen the bolt just enough to allow the distributor to move, turning the tool in a counterclockwise direction. The distributor is now loose, so start the engine. With the aid of the timing light, observe the changing location of the mark on the pulley as I rotate the distributor ever so slightly in either direction. Remember, you're working near the moving fan and belts, so do be careful. Now what I'll do is adjust the distributor until the notch on the pulley lines up with the mark that has the 10 next to it. There. As you can see, the two marks are now in alignment. Now turn off the engine. To finish the job, without disturbing the location of the distributor, gently tighten the hold-down bolt. After doing so, it's always a good idea to recheck the timing to make sure that the position of the distributor was unchanged. And by the way, now is the time to reconnect any vacuum lines or electrical connectors. After you've done that, your car should be perfectly timed. Okay, now we're into the home stretch. The last two things to do are adjust the idle mixture where adjustable and the idle speed. Referring to your owner's manual or the emission control decal, you might notice that there are two references to idle speed. The curb idle speed, which is what we're interested in, is what the engine revolves at when it's hot. The fast idle speed, on the other hand, is what it revolves at when it's cold. You may notice that the curb idle speed for your vehicle might be preceded by a plus or minus sign of 50 or so RPM. This simply indicates that if you're within 50 RPM either way of the specification, then no adjustment is required. If, however, your RPM reading is out of this range, then it should be adjusted to bring it into the manufacturer's specification. An idle speed below this range could cause the car to die at stops. An idle speed above the range could cause it to run on momentarily after the key's been turned off. Carbureted and fuel-injected engines differ in the way in which their idle speeds are adjusted. I'll get to carbureted vehicles in just a moment, but for now, let's look at adjusting the idle speed on fuel-injected engines. Adjusting the idle speed on a fuel-injected engine is usually quite simple. What you're looking for is the idle air bypass screw, which is usually located somewhere in what is called the air horn. Some of them are inset, as this one is, and some of them are external. The emission control decal on this vehicle indicates that the idle speed should be 900 RPM. To check the idle speed, once again, we'll use the tachometer in the dash or the tach dwell meter. The reading on the tachometer indicates that the engine is idling above 900 RPM. What I'm going to do now is take my flat blade screwdriver and make the final adjustment on the idle speed screw. Turning this screw in a clockwise direction will decrease the engine RPM. Turning it in a counterclockwise direction will increase the RPM. Adjust the screw to the final setting of 900 RPM and the job is complete. As you can see, adjusting the idle speed on a fuel-injected car is a breeze. But for those of you with carbureted vehicles, there's a little more to it. There are several methods of adjusting the idle speed on carbureted vehicles. Let's go over a few of the most common. One method involves adjusting what is known as the idle solenoid, found on many American cars, which is located alongside of the carburetor. It will have a small electrical wire running to it. The hex head on the end of the plunger must be turned with an end wrench in either direction until you arrive at the proper idle speed. Many Fords and some AMCs have an idle speed solenoid that rides on a carrier. The position of the carrier is controlled by turning a hex-headed screw, which is 5/16 of an inch in diameter. You'll find a socket helpful here. Again, turn the screw until you arrive at the proper idle speed. Dash pots are similar in appearance to idle solenoids, only they don't have an electrical connection. With the dash pot, you simply loosen the lock nut that holds the threaded portion in position and revolve the pot again in either direction until you obtain the correct idle speed. The most common method of idle speed adjustment on most foreign models and some American cars requires the adjustment of a throttle stop screw. Additionally, there may be one or two idle mixture screws. This is a typical carburetor. You'll notice that there are several different adjustment screws. Now, not all vehicles have idle mixture screws, and even some that do might be set at the factory and not require any adjustment. Again, consulting your emission control decal will be helpful here. If the mixture screw is adjustable, you can usually find it within a spring at the bottom of the carburetor itself. Here is the throttle stop screw, which is always located near the linkage of the carburetor. Now, linkage is a moving part which responds to the throttle or gas pedal. So a good way to identify the throttle stop screw is to locate the linkage at the carburetor first. And by the way, if you come across a screw dabbed with paint, the manufacturer has done this to let you know that the screw is factory set and should not be adjusted. Now, the idle air mixture screw, if you have one that's adjustable, should be adjusted before checking or adjusting the idle speed. With the engine fully warmed up and running, locate the idle air mixture screw and turn it in a clockwise direction until the engine begins to stumble, or by the reading on the tachometer you see that the engine speed is reduced. Now turn the screw counterclockwise just until the engine picks up speed and smooths out. Now, if you have 2 idle air mixture screws, just repeat this step with the other screw. Now that the idle air mixture screw has been adjusted, I'm ready to check and adjust the idle speed. Now, it's important that you correctly locate the idle speed adjustment screw, but don't worry, here's a good way to make sure if you have any doubt. Find the screw that you believe is the idle speed screw. Note the location of the slot on the screw and turn it 1/2 turn in either direction. If the idle speed changes, then you know you're probably correct. If there is no response, return that screw to its original position and look further. If you still have difficulty, consult your mechanic. According to the emission control decal, I see that the idle speed for this vehicle should be 700 RPM plus or minus 50. Now, in some cases, you may have to lift off or remove the air cleaner assembly to get to the idle speed screw, but you may be able to contact the screw with just a long screwdriver. So, checking the RPM reading on my tachometer, I see that this engine is idling at 900 RPM and that the idle speed must be decreased. What I'm going to do now is take my flat blade screwdriver and make the final adjustment on the idle speed screw. Now, unlike fuel-injected cars, turning this screw in a clockwise direction will increase the engine RPM. Turning it in a counterclockwise direction will decrease the RPM. Adjust the screw to the proper setting of 700 RPM, and the job is complete. Congratulations! You've just learned how to tune your own car. I hope that in the last few minutes, I've been able to take some of the mystery out of what an engine tune-up is really all about. You replace a few bad parts that wear out at certain intervals, and you check and adjust a couple of simple settings, and that's really all there is to it. Now, some tune-up steps are going to be easier on certain vehicles than others, but don't let that put you off. Tuning your car can be fun, especially if you do it with a friend. Now, we've covered a lot of ground today, so if you didn't pick up everything the first time through, don't worry. I guarantee that with a little patience and practice, you'll get the hang of it. If for some reason you did have some difficulty, check with your mechanic. He'll be able to show you where you went wrong, and I'm sure you won't have any problems the next time out. If you don't have a regular mechanic, or you're dissatisfied with the one you've been going to, get some recommendations from the people at your local auto parts store. They know who's hot and who's not. You know, it's a great feeling not having to rely on others, especially when it's something we can easily do ourselves. When it comes to tuning your car, you can take special pride and satisfaction in not only knowing that you can do the job, but that you can do the job right. And besides, you can save some of that hard-earned money, spend it on something a little more worthwhile, like yourself. I'm Geraghty. Enjoy the ride.